Hi, welcome to Zona Mechanica. There is an MCQ on block break. Figure at the margin indicates the weightage of the question, that is 2 marks. A block break shown below has a face width of 300 mm and a mean coefficient of friction of 0.25. For an activating force of 400 Newton, the breaking torque in Newton meter is. There are 4 options given. Well, let me draw the figure once again. As you can see in this figure, this is the wheel, rotating wheel. The sense of the rotation is also given, which is clockwise, and the diameter of the wheel or the drum is 300 mm, and this is the block, okay, and this is the lever, okay. The contact angle of the block is 45 degree, okay, and the distance of the center of the wheel from the fulcrum, this is the fulcrum, is 150 mm, which is equal to the radius, okay, and the distance of the fulcrum from the center of the wheel is 200 mm, okay, and this is 400 mm from the wheel center to load end or the right end of the lever, okay, where the activating force of 400 Newton is acting, okay. Let this is the wheel and this is the block, okay, and this is the lever, this is the fulcrum, okay. Once the activating load is applied over here, the block will engage with the wheel, okay, and it will create a pressure on the wheel. In turn, the wheel will provide a normal reaction, right? Let Rn be the normal reaction, and since the wheel is rotating in this direction, so the braking force will act in this direction, right? Let Ft be the tangential braking force, okay, and since the distance of the fulcrum from the center of the wheel is 150 and the diameter of the wheel is 300, that is the radius of the wheel is 150, so these two are same, so we can say that the line of action of the braking force is passing through the fulcrum, okay. So now to get the magnitude of the normal reaction, we shall take moment of these two forces about the fulcrum, okay. Since the braking force is passing through the fulcrum, so the moment is 0 about the fulcrum. So now taking moment about the fulcrum, Rn into this distance, see this is 200 mm, right, 200 mm is equal to the moment developed by the activating force, which is equal to 400 into this distance is 400 plus 200, that is 600 mm, okay. So this is in mm, this is in mm, and this 400 is in Newton, so Rn will come in Newton. So clearly from here Rn is equal to, this will be 1200 Newton. See, the contact angle is 45 degree, which is less than 60 degree, so we can assume that the pressure developed in between the block and the wheel is a uniform one, okay. So the coefficient of friction 0.25 can be used as it is in the calculation, okay. So therefore now Ft will be mu into Rn, we know this, right, so which is equal to 0.25 multiplied by 1200, this much of Newton, This is nothing but 1/4, so this will be 300 Newton, right? Now the braking torque will be Ft. See, braking torque is nothing but this force, this braking force into this distance, that is the radius of the drum or wheel. Okay, this is the force and this is the distance, so braking torque is force multiplied by this distance. Okay, that is Ft into R, radius of the wheel. Okay, so Ft we know is 300 in Newton, and R is, see, diameter is 300, so 150 mm, 150 mm. So if we divide by 1000, it will be in meter, that is Newton meter. Okay, so how much it will be? See, all the three zeros will go and this will be 45 Newton meter. Okay, so this is the braking torque generated by the activating force, okay, over here on the wheel. So clearly it's matching with option C, so option C is the correct answer. Hope you have understood. If you are enjoying, please do share with your friends. If you are new to our channel, please do subscribe it.